Okay, let's keep going then. If there are no questions, let's just keep going, okay? So here's another example. After this one, I was going to let everyone try one for fun. So I figured that'd be good to do. You know, give everyone a chance to try these out. So here, let's suppose that Marie can afford a $250 per month car payment. So she knows that's how much she can afford. And, you know, I guess she goes around to different loan companies. I don't know. But it turns out she can get a loan at 7% interest for 5 years. So she's somehow able to get that. Well, the question is, how expensive of a car can she afford? That's what we want to know first. Then how much total money is she going to pay the loan company, and how much of that money is interest? So again, how expensive of a car can she afford? Well, basically what we're asking is, how big a loan can she get? What's the biggest value P sub 0 could be? Well, that's what we're going to solve for. What is P sub 0 is what they're asking, given these parameters. These values of the variables, excuse me. You know, we're asking how big a loan can she get? That's what we're looking for. You know, because the loan is used to pay for the car. Okay, well, again, it's so P0 I just said is unknown. We're given she can afford a $250 per month car payment. So basically we're saying she can send the loan company $250 per month. That's all she can afford. That's what we're saying here. We have the interest at 7%, so we convert it to a decimal, 0.07. Now remember, we're assuming she's making monthly payments. I know in the other one with the mortgage, I didn't write down monthly mortgage payments. But here, it's explicitly stating per month, monthly payments. That means the loan, the account that is compounded 12 times a year. You know, that's how many months there are. Remember, we're assuming implicitly that the number of times it's compounded, okay, the number of times the number of compounding periods, that's better, excuse me, the number of compounding periods equals how often we make a payment, which is per month. So in a year, 12 times. T, this is 5 years, so she got a loan for 5 years, okay? So we plug in and we calculate. We have our formula. This is a loan, right? This is a loan. So we're going to calculate. So we have our values put in, right? So P0 we don't know. PMT, that's the 250. R is 0.07. N is 12. And T, 12 times 5. Excuse me. Okay. All right. Okay, so let's calculate this. So again, you want to handle the top and the bottom separately. So if you do the bottom first, you get this. Here I actually round it off. I use 7 decimal places, okay? I mean, again, you want to round off the 2 in the very end. So the more you use in your intermediate calculations, the better, the more accurate your answer is going to be. So I just chose 7 kind of randomly. I mean, you can use 4, 5, 6, or whatever, but you definitely want to use more than 2. I would say use as many as you can. So, okay. All right. So the bottom's handled. Let's handle the top. So we divide as well. We also added, that's how we got this here, as you can see. Five times 12, that's 60, right? So we have minus 60. Now, when you calculate this, when you do 1.0058333 to the negative 60, right? What you get is this decimal. You know, you could do that in a calculator. I mean, I didn't use my iPhone calculator. I use the, what do you call it? The calculator in my computer, in my laptop. But you definitely want to use a calculator. And then you do 1 minus that, which gives you this. Then we have this whole thing to calculate, right? Which I rewrote down here. Not sure why I wrote it twice like this, but that's okay. And then when you do this big calculation, you get this. So altogether, the biggest loan she can get, right? We're asking for how expensive a car can she afford, is one that costs $12,625.51. That's the biggest loan she can get. Hence, the most expensive car she can afford is this. All right. So we have that. Now remember, she's paying, I don't know why I wrote we there, but she's paying $200, okay, and $50 each month. And this is for 5 years. I almost said 50 years. This is for 5 years, okay? We want to know how much is she paying in total? How much is she sending to the loan company, that is? So we have $250 per month, right? Times 12 months per year times 5 years, okay? That's what we're saying here. Again, 5 years, this is per month, so you have to also multiply by this to go from months to years. So altogether, we multiply and we get $15,000. That's what we get here, $15,000, okay? Now she's sending more money than the loan payment, right? So assuming she actually does get this loan, she's sending more than that, right? Well, what else is she sending them? The interest, right? Remember, from a loan, there's going to be some interest. Well, how much is that interest, though? Well, we have the how much she's sending, right? How much she's sending. This is the loan amount she's paying off. Anything extra comes from interest. So anything more than this. Well, how do you get that? You subtract 15,000 minus the loan amount she's taking care of, but anything else she's sending is interest. So this is our interest. Okay? This is what we get. All right. Are there any questions about that? Because I figured for the next one, I let everyone try out. It's really very similar to this. Okay, well, so let's say somehow she made a mistake and it turns out she can instead afford $300 per month. $300 per month. Now, okay, now let's say somehow she's able to also get a loan, 9% interest for 6 years. 9% interest for 6 years, okay? So let's say somehow she made a mistake and it turns out from a different loan company, they're offering her a loan of at 9% interest for 6 years. Now we're going to answer the same question. But now you guys are going to, everyone here is going to try it out. I'll give everyone about 5 minutes and then, we'll work through it together. I mean, right away, you should probably be able to see intuitively that this loan is not going to be as nice because the interest rate is higher. Okay, let me just double check. The interest rate, is higher, and it's going on for a longer period. Okay, so maybe this may not be better, but let's actually do the calculations. That is, let's solve this problem. Okay, so what I want everyone to do now is to work on that for a bit. Okay, then we'll do it together. Okay, so let me just stop the record. Let me pause the recording. Take about 5